Electrical discharge machining, EDM, is a highly precise manufacturing process used to machine complex shapes and hard materials that are difficult to process with traditional machining methods. Here's an explanation of what EDM is and how it works. EDM is a non-traditional machining process that removes material from a workpiece using electrical discharges, sparks. It is particularly effective for machining hard metals and complex shapes that would be challenging or impossible to achieve with conventional cutting tools. EDM is widely used in industries such as aerospace, automotive, and tool and die making. It is commonly used for creating molds, dies, and intricate parts with tight tolerances, electrodes. The process involves two main components, the workpiece and the electrode. The electrode is usually made of materials like graphite, copper, or copper tungsten. Electrical discharge. A series of controlled electrical discharges occur between the electrode and the workpiece. These discharges are generated by a power supply and create intense heat. Steps in the EDM process. The workpiece and electrode are submerged in a dielectric fluid, which acts as an insulator and coolant. The dielectric fluid is typically a hydrocarbon oil or deionized water. Gap creation. A small gap is maintained between the electrode and the workpiece. The machine precisely controls this gap to ensure consistent material removal. Spark generation. Electrical discharges occur across the gap, creating sparks that generate intense localized heat, up to 12,000 degrees Celsius or 21,632 degrees Fahrenheit. The heat causes the material on the workpiece surface to vaporize and melt. Material removal. The molten and vaporized material is removed from the workpiece surface, leaving behind a cavity that mirrors the shape of the electrode. The dielectric fluid flushes away the eroded particles, keeping the machining area clean. Electrode movement. The electrode gradually moves closer to the workpiece as material is removed, maintaining a consistent gap for continuous sparking. Surface finish. The process results in a high-quality surface finish with precise details. The finish can be further refined by adjusting parameters such as spark intensity and duration. Types of EDM. Sinker EDM. Die sinking EDM. Uses a shaped electrode to create cavities and intricate details in the workpiece. Wire EDM. Uses a thin, electrically charged wire as the electrode to cut through the workpiece. Often used for making precise cuts and intricate shapes. Advantages of EDM. Precision and accuracy. EDM can achieve extremely tight tolerances and intricate geometries that are difficult with conventional machining. Complex shapes. It is capable of producing complex shapes and fine details with high accuracy. No mechanical stress. As a non-contact process, EDM does not exert mechanical stress on the workpiece, minimizing the risk of distortion. Hard materials. It can machine hard and brittle materials such as tool steel, tungsten carbide, and exotic alloys. Limitations of EDM. Slow material removal. EDM is typically slower than traditional machining methods. Electrode wear. Electrodes can wear over time, requiring replacement or reconditioning. Cost. The cost of EDM equipment and operations can be higher compared to conventional methods. An electrode is a conductive material that is used to make electrical contact with a non-metallic part of a circuit. In various industrial and scientific processes, electrodes play a crucial role in facilitating the transfer of electrical energy. In EDM, electrodes are used to erode material from a workpiece through electrical discharges. The electrode and the workpiece are submerged in a dielectric fluid, and controlled electrical sparks occur between them, removing material from the workpiece. A series of electrical discharges are generated between the electrode and the workpiece. These sparks are created by applying a high voltage to the electrode. Importance of electrode accuracy. Part precision. The shape and size of the electrode determine the final shape and precision of the machined part. Any inaccuracy in the electrode will directly affect the part's dimensions and quality. The accuracy of the electrode also impacts the surface finish of the machined part. Worn or inaccurate electrodes can lead to poor surface quality and defects. If you require precision machining services, feel free to contact us to learn more about our EDM solutions.